This is a demonstration of Charles' Law for National 5 Physics. First of all, the equipment. Got a clamp stand, got a hot plate stirrer, got a magnetic flea, got a ruler, got a couple of elastic bands, we've got a thermometer, we've got a glass tube with a bead of mercury in it, we've got a tall glass beaker, and we've got some cold water. I've attached the thermometer and the capillary tube with mercury in it to a ruler using the elastic bands. So I just called this tube with the mercury in it a capillary tube. But if you don't know what a capillary tube is, here's another one. It's a tube made of glass with a hole in it. In this case, it is open at this end and sealed shut at the other. The one we're using in the experiment today is sealed at the bottom, but open at the top. That is because what we're interested in is this air here, between the sealed end and the bottom of the mercury bead. This is a fixed mass of air down here. No more air will ever enter this, and no more air will ever escape from this. This air will be here, hopefully forever, or at least for as long as this experiment takes. It is a fixed mass of air, and there is the same number of air molecules in there as there always will be, but it's not a fixed volume of air. We can change the volume of air here by heating up or cooling down the air, and that's what we're going to do in this experiment. It is important to have the air column here at exactly 0 on our ruler, because we are interested in the volume of air here. You may notice we're not actually measuring volume, we're measuring height of the mercury. That doesn't matter. We can actually use this as a volume because this tube is perfectly uniform. So I've moved in the camera a bit closer and you should be able to see the bead of mercury down here and the thermometer reading 20 degrees Celsius. But we're going to change that by adding cold water to the beaker. So I've added cold water to the beaker. I will turn on the magnetic stir to keep the water circulating, and we are reading 6 degrees Celsius and the bottom of the mercury is at 7.8 centimeters up the ruler. So I'll go and write those two values down as our initial values. So the next step, I'll turn on the heater on the stirrer hot plate. We'll start warming up the water and see what happens to the mercury. This will take a while, so I'll cut between the times when we reach a different temperature. The thermometer is now reading 10 degrees Celsius and we're still at 7.8 centimeters up the ruler. We're at 15 degrees Celsius and we're 7.9 centimeters up the ruler. Also getting some lovely refraction there from the water-air interface. We've just reached 20 degrees Celsius and we're 8.0 centimeters up the ruler. Remember, significant figures are important. We're at 25 degrees Celsius and 8.1 centimeters up the ruler. Hopefully we're beginning to see a bit of a trend between these two values. We're at 30 degrees Celsius and 8.2 centimeters up the ruler. Have a think what the graph for these results should look like. We're at 35 degrees Celsius and 8.4 centimeters up the ruler. 40 degrees Celsius and 8.5 centimeters up the tube. We're at 45 degrees Celsius and 8.7 centimeters up the ruler. Have a think and see if you can predict what the relationship between temperature and volume is. Remember that the height here on the ruler is representing the volume of air underneath it. Now we're at 50 degrees Celsius, there is 8.9 centimeters of air in the capillary tube. That's probably enough results for this one experiment, so I'll turn off the heat and let everything cool down. So I'll put all the results from this experiment in a table which I'm going to show you, but I'll leave you to do the calculations. You may want to think of ways to improve this experiment. Perhaps a bead of mercury in a capillary tube in a beaker of water isn't the most scientific approach. Perhaps you could use different equipment or a different method to calculate Charles' Law. Have a think and see if you can come up with anything better.